Have you ever accidentally changed the formatting on a spreadsheet that had dates in them and saw all of the dates change to random numbers? What's that number all about? Why did Excel make a date that specific 5-digit number? Well, it turns out that according to Excel, dates are numbers. In fact, each date equals 1, and time is a fraction of 1. So for example, 12 noon would equal 0.5, or 6 p.m. is 0.75, and so on. And that seemingly random 5-digit number, it's actually the total number of days since the very first day Excel recognizes, January 1st, 1900. The brilliance of this little bit of programming is that as long as you aren't tracking dates from the 1800s, any two dates can be thought of as simply X number of days and Y number of days since a common day. Meaning you can treat dates as numbers, and we can add and subtract them. Want to see what date an invoice is due if it's 90 days from today? Simply add 90 to the date. Want to know how overdue an order is? Simply subtract the due date from today's date. Once you start thinking of dates as numbers, all kinds of things become possible. And to demonstrate how you can take advantage of that fact, let's do something really fun and find some unconventional birthdays by calculating how many months, days, or even hours old we are. One of the most romantic things I ever did was celebrate my wife's 1 billionth second on Earth. All thanks to the power of Excel. In the sample file, let me do a quick experiment to prove my point. First, I'll hit the keyboard shortcut, Control semicolon, which will quickly put today's date in a cell. Then I'm going to select that cell again, and Control-Shift-1 changes the formatting to a number format. And you'll see today's date is actually just a number. Okay, now let's put in our birthday. If you know your birth time, put that in as well. Just be sure you include a space between the date and the time, as that is how Excel is going to recognize a date-time format. In the cell marked current date, you could use that keyboard shortcut Control semicolon again, but that's a static value. So instead, I want this file to show current date every day, so I'm going to use the formula equals today with open and closed parentheses. Nothing goes inside these parentheses for this formula. It simply equals the word today and then those parentheses. And that'll give me today's date every day. Okay, we've got our variables. Now it's just simple math. In the next cell, I'll write a simple formula where I'll take today's date and subtract my birth date. If the result looks a little weird, it's just because of the date formatting. Switch back to the number format with Control-Shift+1, or from the Home tab, where you can have it in the drop-down menu. And there you go, how many days old you are. If you're in your early 30s, you're coming up on your 10,000th day on Earth. Pretty exciting. Great excuse to have a party. We can keep this going with time. If you want to be precise based on that time you were born, go back to that current date field, and instead of using equals today, change it to equals now with those same open and closed parentheses. The now function gives you the current date and the current time together. And by the way, that's pulled from your computer clock, so it's based on your time zone. Click the cell where you want to put how many hours old you are, and this is just simple math. We're going to take how many days old we are from that previous cell and multiply by 24. Now you get how many hours old you are. Next, you could multiply that new cell by 60 to get how many minutes old you are. And if you really want to see a big number, I'm going to take that previous cell, multiply it by 60 again, and here's how many seconds old we are. Now I'm just going to go ahead and clean this up by removing some of the extra decimal points, but if I really wanted to confirm that this is in fact accurate, I might want to recalculate how many years old I am. So I'll simply take that how many days old we are and divide by 365.25. We can't forget about the leap year, and neither does Excel. And there we go, how old you are, and unfortunately how old I am. So there you have it. If you discovered a new kind of birthday coming up, share it in the Q&A section, and we'll all wish you a happy birthday. See you next time. Excel has two default options that appear in the format list when you're formatting a date. You can use the short date format, where a date like, say, March 6, 2019 would be 3/6/19. or the long date, which spells out the weekday and the month and uses commas. So that would display as Wednesday, comma, March 6th, comma, 2019. But there are so many other ways you may want your dates displayed. Maybe you want the weekday and month abbreviated to their 3-letter versions. Or maybe your company is European and you want the dates formatted as a day, period month, period year in that different order. Maybe you want the leading 0 and the full years like 03/06/2019. In this lesson, I'll teach you first how to create any custom date format you want, and then how to customize the default date format across Excel. So, these two date format customizations happen in completely different places, but we'll start with creating a custom format for your dates. First, let's put in today's date, again with that keyboard shortcut, Control, or if you're on a Mac, Command, semicolon. Now we want the format for that date, and here's another free keyboard shortcut for you. With that date selected, hit the keyboard shortcut Control-1 or Command-1 on a Mac. This opens up the formatting dialog box. Here you can see all the stored date formats under the date category, and there are a fair number, but there's also an option at the bottom of this list of format types to create custom formats. That's where we're going to go. Okay, when you click on custom formats, you're entering an entirely different approach to formatting. Here, we encode a format by using certain characters in specific sequences. Scroll about halfway down this list, and here we start to see some of those date formats. I bet you can guess that the D's are for days, M's are for months, and Y are for years. Also note the H's, M's, and S's, those are for hours, minutes, and seconds, as well as the AM/PM to indicate 12 versus 24-hour formats for time. The trick here isn't just what the letters are that you use, but how many you use. For example, a format with 1 M means just the number. 2 M's means the number but with a leading 0. So September is 09, not just 9. 3 M's is going to give you the abbreviated text version of the month, and 4 or more M's will give you the fully spelled out month. Same rules apply for days of the week. 1 D is just the number, 2 D's includes the leading 0, 3 D's is the abbreviated day, and 4 is the fully spelled out weekday. Everything else, from the order they appear, to the dividers you use, to the combinations or even extra text, is entirely up to you. All you do is write the sequence from this top bar here and then hit enter. For example, I'm going to make an especially complex date format to demonstrate this concept. I want to take any date and format it to say the words today is, and then a colon, which I'm going to put in quotes here so that they appear as text, then a fully spelled out weekday, so that's 4 D's, then a colon and a space, and then the abbreviated month, so that's M's, another space, just the day number with 1, and then sadly there's no way to include the second, third, or fourth suffixes, but that's okay. I'll also put the year here, but maybe we want to include this date as how it would display in a European format also. So let me add a comma, and then some parentheses, DD, period, MM, period, YY, and close those parentheses. Note in the preview window this awesome and complex format we've just made. Now simply hit enter, and your date value now displays in this fancy new way without having to store all that extra stuff in the cell. Remember, this is still just a date. When you hit enter, you actually save the custom date format, and you can go back to that custom format with the Control-1 and see that it's actually been added to the bottom of the custom list and will be available across any Excel file from here on out as long as you go to this custom list. Now, if you want to change the default formats of your dates, so the short versus long options, this is actually done at the computer operating system level, not the program level. So in Windows, we're going to go to the region settings. On Macs, it is region and language. Under set regional format, we'll go to the date and time section, and then scroll about halfway down the list. You'll see the date and time regional formatting, and then about halfway again, you'll see the regional settings, and then region. Here is where you'll find all of the settings to change your short or long dates. For example, I'll change my short date to the European format of day, week, and month. And now when I change short date in Excel, we see that it automatically updates to day, week, month. Remember, dates in Excel are nothing more than numbers formatted to look like dates. So everything you just learned here is not changing or modifying the actual date value you entered in the cell, it's only changing how it's displayed. So go nuts! Inserting or deleting rows and columns in Excel is a fairly straightforward process. However, there are a couple of tips and tricks of the trade that can make it much easier in a variety of situations. In this lesson, I'm going to teach you the keyboard shortcuts and best practices for inserting and deleting individual rows and columns, sets of rows and columns, and even how to insert new rows or columns in between existing data. Let's get right into it. So here we have a typical list, and maybe I want to add 2 or 3 blank rows on top of the headers, and maybe another column here to be full name. A couple of things to keep in mind. First, remember the cardinal rule of Excel, select and then effect, meaning we'll first need to select the entire row or column to indicate that's what we're inserting. There's a great keyboard shortcut for this, which is Shift and the spacebar to select a row, and Control or Command spacebar to select a column. The second thing to remember is that Excel will always insert new rows above your selection and new columns to the left of your selection, always above or to the left. Meaning, if I wanted to insert that column of full name between columns B and C, I would select column C, and I'll use that keyboard shortcut Control or Command spacebar from any cell in that column, and then I could right-click on my selection to see the Insert option, but there is, of course, a keyboard shortcut for inserting. That keyboard shortcut is Command or Control and the plus sign. Again, Control for PC, Command for Mac. Unless you have a number pad on your keyboard, then it is actually Control and the dedicated plus key. That will do an insert. So, Control-Shift equals. Note this isn't an insert column keyboard shortcut, it's an insert selection shortcut, meaning it is the same for both rows and columns, and if you just had a cell, it would just insert a cell. So, whatever is selected, I insert with that Control plus keyboard shortcut. Okay, so what if you want to insert more than one row or column at a time? Well, that's easy too, if you again remember that cardinal rule, select and then effect. Say I select the first row below my headers with that Shift spacebar. Then I could hold down the Shift key and use my arrow keys to select multiple rows at once. Of course, you could have clicked and dragged across those row labels to do the same thing, but I like to use my Control keyboard shortcuts and the arrow keys because now my hands are still on the keyboard. And with the Control-Shift equal, it inserts as many rows as I've selected, all above my selection. The same thing would work with columns, of course, but let me use this opportunity now to show you one final bit of tradecraft. Sometimes you don't want to add a whole new set of columns, all bunched together, a whole new set of rows all bunched together, and instead you want to add them in between each existing row or column, almost like you're spreading your table out like an accordion to maybe alternate options inside those columns next to each existing column. This is actually more easily done with a mouse, and what you're going to do is rather than clicking and dragging or selecting a whole range of rows or columns, and I'll do this on columns here, we're simply going to select the second column, and then with a Control or Command click, I'm going to click on the third and the fourth and the fifth column and so on. And you'll notice that with that Control click, it looks a little different than your typical click and drag because it's a non-contiguous selection. And when you select non-contiguous or not touching columns, now when you use that insert shortcut of Control-Shift equal sign, it's going to insert in between each of those individual columns, just like that. One final tip is deleting your selection with the keyboard shortcut, and it's oh so logical. It's Control or Command minus. I hope you learned something new that you didn't already know about this fundamental Excel activity of inserting rows and columns. Remember to select with those keyboard shortcuts of Shift spacebar for rows and Control or Command spacebar for columns. Then effect that insert with the Control plus or Control-Shift equals. Now show off to your friends and colleagues and tell them they got to take this course. If you aren't already using the autofill tool, which is that little box that appears in the bottom right corner of any selected cell or range of cells, then I'm about to change your life. And if you are already using that autofill tool, then I'm about to show you just how versatile that tool actually is, because it's one of the best, and it does a lot more than people realize. Because that autofill isn't just about copying data, it copies patterns. Let me show you some examples. Now, the way most people use autofill is for formulas. So for example, I could add a simple sum function to this first row of headers, and rather than having to recreate this function over and over, I can use the autofill handle, which appears in the bottom right corner of the cell. Note that when I hover over that spot, I get the black plus sign. That indicates that I'm in the right place. And then with a simple click, hold, and drag, I can copy that formula down. Note that this automatically recreates the formula using these nice references for each row known as relative references. And of course, that would work across rows as well. If, for example, I selected the first cell in the row total at the bottom, a click, hold, and drag across will do exactly the same thing. But the autofill handle is a lot smarter than simply copying formulas. In fact, it knows patterns. Let me show you what I mean. Let's start with simple text. I'll put in my name, and then once again selecting my name and hovering over the autofill handle. With a click, hold, and drag, I can copy my name as much as I want. Let's say I also wanted to put a little bit more information, like Alex 1. Now when I select that cell and use the autofill handle, autofill is smart enough to recognize I want to do a pattern and extrapolate those numbers out. Now by default, let's say I just wanted to make a list of numbers. If I just put in the number 1 and use the autofill handle, it's actually going to assume that basic copy. However, I can also indicate a pattern, for example, 1 and then 3. Now when I select both of those numbers together and click and drag, Excel knows to add 2 to each line, and I get a series of odd numbers. Remember that in Excel, dates are also seen as numbers. So for example, I could do this with dates. I'm going to put in today's date, and we'll go ahead and format this as a long date so that we can really see what's happening. With that autofill handle in the bottom right corner, a simple click, hold, and drag, we see that Excel is going to extrapolate out all the subsequent dates automatically. However, Excel can let me do more complex patterns, including formatting. For example, let's say that every other Friday is payday, and I'm going to select that second Friday and make it yellow. Now, as long as I select one full sequence of this pattern, that would be Monday through the second Sunday, now with that autofill in the bottom right corner, I click and drag as far as I want to go, every other Friday will now be highlighted for my payday. Excel also knows some innate patterns. For example, it knows the days of the week. If I put in Monday and use the autofill handle, without the dates, it will still know the days of the week. It also knows abbreviated days of the week. So MON will extrapolate out the abbreviated days of the week. It knows months of the year. Let's say March, starting with March, with that autofill handle, it'll know the fully spelled out months and the abbreviated versions of those months as well. One other really cool thing about autofill is not only does it know patterns that actually exist, it also will take guesses at patterns. Meaning, if we went back to our first sheet and I wanted to take a guess at what the next 4 quarters might look like, I could, in fact, select this data. There's no obvious and discernible pattern here. However, with the autofill handle and a click and drag to the right, it's going to use the classic y equals mx plus b, in other words, the slope of a line, to take a shot or a guess at what those subsequent values would be per row. In fact, if I do a quick insert chart
just to see what this might look like, we can see how as the fifth quarter began, all of these lines became linear, and we see the slope of the line extrapolated with a simple click and drag using the autofill handle.
So there you have it, the autofill handle. It's a lot more than just a copy. It's a pattern recognition and recreation tool, and it will save you a ton of time. Let's talk about lists in Excel versus formatting lists as tables. Now, a list in Excel is something we've seen in a bunch of lectures already, and I'm sure something that you're using all the time in Excel. It's simply a series of columns and rows where the columns represent individual fields or attributes that you're tracking, and the rows are individual records. And in case it hasn't been clear, remember that entirely blank rows or entirely blank columns, those define the edges of your list. So never use blank rows or columns when you're trying to format or space your list. No blank rows or columns. Now, with a list, we can do all kinds of things, right? We can sort it, we can filter it, we can add formatting, and even conditional formatting that helps your data stand out. You can create pivot tables or charts from that list, but there's also this option to format your list as a table. And while it may appear to simply be a way to add easy formatting to your list, there's actually a super powerful functionality that comes when you format your list as a table. It lets Excel automatically detect and include any new records you add to that list. Let me demonstrate what I mean. Here we have a list with salespeople and their sales totals for a given month. This list looks perfect for a chart. So I'm going to do a real quick demonstration to make a chart. We'll just select the data, and then under the Insert tab, I'm just going to click and do a basic column chart. We see one column for each month, and the colored parts of each of those columns, those represent the different salespeople. But wait a second. Let's imagine that I've got this simple table, and it's a few weeks later now, and I want to add another month of sales. If I start typing those into my original data set, as you'd imagine, the chart is unaffected. In fact, if I wanted this object, which in this case is a chart, but it could be a pivot table or anything else, to reflect that new data, I'd have to manually edit that range. Now imagine a more complex scenario where maybe these new sales values are added automatically from some other sheet that it's linked to, or maybe there's a dynamic import that happens every other day. So every time that you wanted to visualize the latest data, even though the information is automatically added to the list, you'd have to manually edit the chart. What I'm going to go ahead and do is show you how to fix that problem. First, let's delete this original chart, and let's try it again. But this time, first, I'm going to take my list and format it as a table. It's a super easy process. You simply click anywhere in the data under your Home tab, and then click that Format as Table button. You can choose whatever format style you want, and there are a bunch of styles here, as you can see. Remember that all of these colors are actually based off of your spreadsheet's theme color, so if you wanted to change the color choices you have, that's controlled under the Page Layout tab on the far left side. I'll just pick a random format here for now. Now, in addition to that formatting, note this new little corner in the bottom right of your table. That corner is an indicator that if you add new rows to the bottom of this list or new columns to the right of this list, Excel will automatically incorporate those as part of the table. So what does this mean in practice? That means if I once again make that chart from this data, the same way we did before, Insert tab, I'll choose the column. Let me do a clustered column chart here just to show you something new. And now if we add that new month's worth of data, you'll see Excel automatically picks that data up and adds it to the chart directly. This is also true for any other object like pivot tables or something else. As soon as you turn that list into a table, it will reference the entire data set even when you add new data. This is also true for functions. So if I do a sum function, let's say for a given month, note that I'm not referencing the cell area directly in that formula. Instead, I'm referencing this new table field reference. And what that means is if you manually type in the cell addresses and overwrite this function, it would work, but a click and drag will use this dynamic naming convention. So that if we once again added more data, like let's say a new salesperson with totals were added to that month, It now gets automatically included in the sum. I don't have to edit that function. The Format as Table option may seem like a simple formatting action, but this ability to dynamically include new data makes it an incredibly powerful tool to make it much more efficient and easy to manage lists that are regularly updating. If I were you, I'd be formatting my lists as tables whenever I get the chance. Do you ever find yourself with data running down a column and you wish you could just transfer those to go across a row and use them as headers maybe? Or maybe you have a table that you just want to kind of rotate around or swap so that the columns turn into rows and the rows turn into columns. Well, I've got good news for you. In the next couple of minutes, I'm going to show you how to do just that as easily as if it were a copy and a paste with a tool called Transpose. In fact, this action is very much a copy and a paste, except we're going to use the Paste Special dialog box. So here we have a list of months that I want to turn into a row of months. First, I'll select that list, and then I'll simply copy it with Control-C. And then with a right-click, you'll see the Paste Special option. Note we have to do a copy, not a cut and paste, because the Paste Special is grayed out off of cuts. So we'll just do a copy and then a right-click Paste Special, and you should find yourself in this fancy Paste Special window. Maybe you've used it before to paste values only, but there's a lot more here, including this checkbox in the bottom right-hand corner to transpose your copied data. Check that box, click OK, and voila! You've pasted across the row as simply as a copy-paste. Note the top and bottom converts to the left and right order, meaning this action is reversible. I could select those same values across the row, right-click, copy-paste special, and transpose again to convert those row values into column values. Pretty straightforward, right? Well, here's where it really gets impressive. You could do this with entire tables of data. Here I've got a simple sales totals list where each column represents a quarter, each row is a salesperson, and I want to select the whole table, copy it with a Control-C, then just below I'm going to select my destination cell, right-click, get to the Paste Special window, and click that Transpose again. When I hit OK, now each row is a quarter and each column is a salesperson, just like that. And let's just double check the results. If we look at our first salesperson total in that first quarter, we can see that they match in both tables. The identity of our tables remained intact. We simply swapped the rows and columns. The ability to transpose your data is a great tool to add to your quiver. I use it all the time, and I hope you enjoy it and use it wisely. Enjoy. If there's one thing I can't stand when working with other people's spreadsheets, it's having these large lists where there's more data than can fit on the screen, either down or across, and where the data is sometimes ambiguous. So what I end up having to do is scroll down to a particular record, and then I realize I don't know which column has the information I should care about, so I got to scroll all the way back to the top to see the header row and identify the right column. Likewise, I hate it when the name of a customer or a person of interest is in the first couple of columns of a table, and the information I need is sort of towards the end of that table, and I end up having to scroll to the left, and then scroll to the right, and then scroll back to the left and back to the right, all to figure out which value matches the person I'm looking for. Wouldn't it be nice if we all just agreed as a society to use the Freeze Panes feature and eliminate this headache? It's easy to use. Its only consequence is it makes your lists more user-friendly, and I think we'd all be happier if we just started using it as a society. Let me show you how it works. Here we have a perfect example of a big list where there are so many rows that when I scroll down to see some of the ones towards the bottom, I lose the header row. And when I scroll to the right to see things like email address, I lose the name column. However, under the View tab, you'll see several tools for something called Freeze Panes. I'm going to click the Freeze First Row button, an action that everybody should be taking with all of their big lists, because now, watch what happens as I scroll. Everything scrolls as it should, except that header row sticks with me. What a blessing. Note that on the View tab, there's also a Freeze First Columns button, which would do the exact same thing as the Freeze First Row button, but in my case, it would only actually freeze the ID column, not my far more important name column. These two buttons that we see, the freeze first column, freeze first row, are limited to row 1 and column A, meaning if I happen to have a table with maybe a title in row 1 and then a blank row and then my headers, these two buttons just freezing rows and freezing first columns, they wouldn't help me. That's where this third button comes into play. Right now, it just says unfreeze panes, which, as you might guess, is the way that I undo the other two buttons. So I'm going to go and give that a click right now. And if I now don't have any rows or columns frozen, what this button says now is freeze panes. And what it's going to do is freeze any columns that are above or to the left of my selected cell at the moment I click the button. So let's say here that I have a couple of extra rows at the top of my list, and I need to freeze the first two columns, right? So I'm just going to add a couple of rows here, and now I'm going to freeze these first two columns as well, not just that first column. So if I select the cell to the right of the name column and just below the headers here, now when I click the freeze panes button, note those same little black lines that appeared before now appear again above and to the left of that selected cell. Wow, we see we've achieved a glorious and simple way to scroll around this sheet. I implore everyone watching this video to take the time to think of those with whom you share your spreadsheets, and from this day forth, freeze your panes. Making it easy to see your data all at once and all clearly in a spreadsheet is super useful when you're trying to read or find data in your spreadsheet. Now, by default, text in a cell will never be more than one line of text. And if there's more text than the width of the column, it's going to bleed out into the subsequent columns rather than automatically go to a new line like it would in other programs like Word or Outlook. That is, unless there's data in that column next to it, in which case the text is now just going to get cut off and seem to disappear behind the other columns, completely unreadable. However, there are three solutions to this problem, and we're going to explore them in this lecture. One is resizing your column to fit the data. Another is using text wrapping to increase the height of the row to get the text to go on to new lines. And the third is shrinking the font size just so to get the text to fit in the allotted space. And in this lesson, I'm going to show you when, why, and how to most effectively use each of these options to be able to better read your data in Excel. Let's start with resizing your columns. Now, you can manually resize a column by hovering over the divide between two columns along the column label area at the top of the page. And with a click and drag, you can change the width of whatever column is to the left of your cursor. But there's a much better way to do this with the auto-fit. Auto-fitting columns makes them exactly as wide as they need to be, but no wider. So if I use that same spot, the dividing area between two columns, and I put my mouse there, but instead of a click and drag, I'm going to double click. What that does is automatically resizes the column to the left so it's just big enough to fit all the data in that column. Note that this works to both increase and decrease the width of your column. So I can shrink that ID column also with a double click to make it just as wide as it needs to be. And you don't have to do this one at a time either. In fact, if you select multiple columns or even the entire sheet, I'm going to click in the upper left-hand corner, which selects the whole sheet. Now, a double click between any two columns will auto-fit all the columns at once. That's option one, and it's usually the right choice, except when you sometimes have whole paragraphs of information or really long sentences, in which case a super wide column of one row just won't do. And in those cases, you want to use the wrap text option. What this does is allows the text in a cell to wrap to multiple lines and auto resizes the row height to be just big enough to fit all of that data. Note, however, that the width of the column is going to still remain constant. Also, when you first apply the wrap text, it's going to auto-fit the row height, but it's not going to adjust after the fact. So if you do the autofit on this column and then you manually resize your column to whatever size you feel like it makes sense, you'll actually want to use the autofit again on those rows. So we'll select the entire sheet from the upper left and double clicking between any row labels. It's easy as that. One final choice that you might want to use is for those rare times when you don't necessarily want to change the width of the column or the height of the row, you just want the data to fit in the current cell. For example, this may make sense when, say, you're printing your data and you only have a few cells that contain longer than average text strings, but you don't want to make the whole column bigger to accommodate those cells. Basically, if you would prefer a different font size to different row heights, or need the column width or the rows to stay how they are, you're going to want to use the Shrink to Fit format option. You'll find the Shrink to Fit option in the Format window. So all you have to do is select either the individual cells or an entire column, and then with a right-click Format Cells or the keyboard shortcut Control-1, and it's Command-1 on a Mac, under the Alignment tab, you'll see an option to Shrink to Fit. And if you check that box, this is going to make any text that doesn't fit in the cell size currently shrink its font until it just fits. And one really cool thing about this format setting is that it's going to change the font size as the column width changes. Watch as I shrink or expand the column now. Kind of neat, huh? So there you have it. 3 different ways to format your spreadsheet so it's easier to read. I use these all the time just to make it more user-friendly to deal with my spreadsheet. I'd also say that the order we covered it in is the order I would consider when deciding which ones to use. You'll start with the autofit. If a column is too big, you'll then do the wrap text. And if you must, you'll use the Shrink to Fit. The people reading your sheets will thank you for the effort. See you next time. By most counts, Excel 2019 has just cracked 480 different functions. These functions include those you know and love, like sum or average. Some you may be intimidated by, like VLOOKUP, and even new functions like switch or if-else. Each function has its own special capability, its own unique purpose. But all functions in Excel, from the simplest to the most complex, use the same basic grammar, the same syntax. And once you understand this basic structure, you'll be equipped to quickly master any function you want to use. Let's take a look at how to do that. So here we are, the master rules for all functions. First, anytime you're doing any kind of calculation, you always start with the equal sign. This tells Excel that you want it to do a calculation, not display whatever you're going to write. Next, after that equal sign, you always put the name of the function, whether it's the sum or word count or VLOOKUP or if-error, whatever it is. This tells Excel what type of calculation you want to do and sets you up for the next step. All functions have open and close parentheses after the name. And within those parentheses will go the variables, or the stuff that makes this function go. These variables, which are always separated by a comma, are the only things that change across functions, and are set by the function name. That's it. All functions start with an equal sign, then the name of the function, then open and close parentheses within which go the variables. Once you understand this universal concept, the only real question you need to ask yourself is, what variable does this particular function need?
Let's give this a try in a blank Excel file. I'm going to start by entering in that basic syntax. We start with the equal sign, then the name of the function. We'll use a common one like sum, and then those open and close parentheses. Note when I first hit the open parentheses, it's going to give me the names of some of the variables, and when I close those parentheses, it disappears. However, note this little button just to the left of the formula bar, the FX button. If you give that button a click, you're going to get this really useful dialog box. It'll appear on the right-hand side in Macs. And what this dialog box will do is give you all of the additional information you may need to understand the variables. First, note that the variables are listed here at the top with the required variables as bold. If I click on additional variables for sum, you see these are all optional. I really only need one range of cells to sum. Also note just below that you get a nice description of that variable, including what Excel is expecting in this variable area. A logical value and text are ignored in cells. If you're still confused about how to use this function, note the Help on this function button at the bottom. This will open up Microsoft's help files on your web browser, and it will include a variety of detailed information, including things like common problems that you may come across when using this function. Let's take a look at this on an even more complex function, the VLOOKUP function. Once again, we'll use the basic grammar, the syntax for all functions. Start with the equal sign, then the name of the function, in this case VLOOKUP, followed by open and closed parentheses. When I put in that open parentheses, we see the variable names. We'll close those parentheses and then once again hit the FX button to the left of the formula bar. Note for the VLOOKUP, I have 4 variables, 3 of which are required, indicated by bold. The last one is not required, meaning if you left it blank, the function would still work and use the default setting of the range lookup variable. Now, VLOOKUP is especially confusing as a function because of these archaic, weird names of lookup value, table array, column index number, range lookup. It's really not clear what those are supposed to be, but note that as I click in these variable fields, I get these nice descriptions at the bottom, helping me to understand how this function works. And of course, if you're still confused, the Help on this function button, not only does it include more detailed descriptions, it'll include examples, it'll even include this video so that you can play to help get some additional information.
And if VLOOKUP is still something that folks are interested in, let me know in the Q&A and maybe we can cover it in a future lecture. So if you remember that all functions, regardless of what they are, use the same syntax of equal sign, name of the function, open and close parentheses within which go the variables divided by commas, you will be equipped to create any function. And with that scaffolding, you can build cathedrals in spreadsheets. I look forward to showing you how. See you next time. Excel isn't all numbers and formulas. In fact, we often have lists full of words. And dealing with text, for example, extracting certain characters from a text string, is a crucial skill to add to your capabilities. For example, maybe you have a column full of phone numbers and you want to pull out just the area code so you could group or filter that attribute. Or maybe you're working with a product SKU code where, say, the last few digits of the string or even a few letters in the middle indicate something important. You need a way to extract specific parts of a character string. And in this lesson, you'll learn about 3 functions that can help you do that: the left, mid, and right functions. Each of these functions works basically the same way. You just point the function to the character string and then tell it how many characters you want included in the result. Now remember, as far as Excel is concerned, everything in a cell counts as a character, whether it's a number or a letter, a space, or even a bit of punctuation. So for that example earlier of a phone number, the main number actually starts at the 5th position after the 3-digit area code and the open and closed parentheses. So let's take a look at this in action. In the sample file, I've set up one column that has some interesting data in it. We have some fake credit card numbers where it turns out, and this is true by the way, the first digit of the number indicates the bank. 3 is American Express, 4 is a Visa, 5 is a MasterCard, 6 is a Discover card. So wouldn't it be nice to be able to pull out that number and ID the card types in a different column? We also have this special ID string where we're going to imagine that the middle 2 characters are where this product was produced, and then it's followed by a 4-digit item code. And what I want to be able to do is extract those 2 bits of data from this same one text string. Let's start with extracting the first digit of the credit card number. In the blank cell for credit card type, we'll start with the equal sign, as always. Then the name of the function, in this case it's left, L-E-F-T, followed by open parentheses. And note the variables we need when we start this function. We're going to need to put in text, which is the location of the string, and numChar, or number of characters to extract. In this case, the cell with this text string is our first credit card number, and after a comma, the number of characters we want is 1. We just want that first character. We'll close the parentheses, hit enter, and when I copy that formula down with our lovely autofill handle, voila! All the credit card types are extracted and ready for sorting. Now to extract the item purchased, which is those last 4 digits of our purchase code. Since we want the last few digits, not the first couple digits, we use the write function. Click in that first cell in the next column and add the equal sign, then the word write, R-I-G-H-T, and an open parens, and we see the same 2 variables, text and numChar, or number of characters. We'll select that first code for our text, then a comma, and because we want the last 4 digits, we'll put in the number 4. Close the parens, enter and copy, and you see we've extracted those digits from the write. Now, for the mid function, we want the 2 characters representing the state that are in the middle of our code. In the state column, we'll start with the mid function, and note that with that equals mid open parens, instead of 2 variables we needed for the left and the right functions, the mid needs a 3rd variable. We still need the text function to point to the string, but before that number of characters, we also have to give it this start num, or what position our first character starts in. So it's counting from the left. So if I count from the left, we see that the first letter of the state is the 4th character in all of these strings. So my start number is actually 4. Then a comma, and we only want 2 characters for the number of chars, so we'll put 2 for the last variables. Close our parentheses, copy that down, and there you have it. We've extracted those values. The left, mid, and right functions are the starting blocks for how you manipulate text in Excel. Once you understand how they work, you'll be able to start trying more advanced techniques that we cover in some other lectures, including how to start extracting characters from a variable location. We'll save that for another time, though. See you later. I love today's topic, and it's something I use all the time in my day job. We're going to see a super useful technique that lets you combine multiple character strings into a single cell. For example, maybe you want to build the email addresses of a whole bunch of people where you take the first name, add a period, and then add the last name and then tack on an @companyname.com. Or maybe you're trying to display information with a little bit more context, like instead of just a calculation that gives you a number, you want to add a label to that number, like say adding the word owed to a formula that calculates the total bill minus the total paid. So it says blank owed. This action is called concatenate, which Webster's defines as to link things together in a chain or series. Now, there is a concatenate function in Excel that will do this, but we're not going to use it because A, concatenate is the longest function name ever to have to type out, and B, there's a way easier shortcut. Simply using the ampersand or the and symbol above the number 7 on your keyboard instead. So let's take a look at how this works. We'll start here with a simple example. Here we have a first name and a last name column, and I want to make a full name column that puts these 2 cells together. It's as easy as in my full name column typing equals A2 for the first name, the and or ampersand symbol above the number 7 on your keyboard, and then B2 for the last name. When you hit enter, there you go. First name and last name together. Of course, we didn't exactly tell Excel what we wanted because it didn't intuit that we wanted a space between those 2 words. So let's delete that and try again. We'll again put an equal sign and then reference cell A2, then that ampersand or and symbol, and we want a space now between first and last name. So for any text in a formula, you want to represent that text inside of quotes. So we can do this by putting quote space quote. Now I'm going to do another ampersand symbol and then put in B2. So now if you read this as a sentence, you're simply saying this cell should equal whatever is in A2 and a space and whatever is in B2. Hit enter, copy it down, and you've made a full name column. You can make this string as complex as you like. For example, making an email address. In fact, let's use a concept you can find out more about in the text function lecture. Now, let's assume that the format of your emails at our company are the first letter of the first name and then the last name at acme.com. To get that first letter, we'll use the left function. So in this next cell, we'll say equals, left, open parentheses, then the location of our text, which is A2, and the number of characters we want, in this case 1. So left, A2, comma 1, and close those parentheses. But before I hit enter, let's add the last name by simply keeping this formula going. We'll put in the and or ampersand symbol again, and then B2. Next, we want to add the domain, so another and symbol, and then quote at acme.com, close quote. Read it like a sentence, and what you see you're asking for is one character from the left of the first cell, and whatever is in the second cell, and the text at acme.com. Hit enter, and you've built yourself an email address. Last example, just to show you how this can work with augmenting calculations. Say that I want a cell that says something like X dollars is Y days overdue. Like for this first example, the result should say $300 is 30 days overdue. So I want the amount due with a dollar symbol, and then the word is with a space before and after, then the difference between today's date and the due date, and then finally the word overdue. Because this is going to be a cell with text in it, I can't actually format that number as currency. So I'm going to fake it by starting with the dollar sign in quotes. So equal sign, put the dollar sign in quotes, then an and symbol. And now we're going to reference E2 and another symbol with quote space is space close quote. Got to remember to put those spaces inside of the quotes. Now we're going to do my calculation. G2 minus F2. Then we're going to do another and symbol. And finally, quote, space, overdue, close quote. Hit enter, copy it down, and you've produced a dynamic phrase for each customer. Great for things like mail merges. Concatenate using the and symbol is a great little technique that I personally find uses for all the time, especially when I want the result of a calculation to come back with a bit more customization than just the value. Give it a try yourself and enjoy, and if any of your colleagues comment on it, tell them to watch this lecture. Say you've got a bunch of full names with first and last name, and you're planning to do a big mail merge where you just want to say dear first name. So you need to somehow separate out the first names from the last names. Wouldn't it be nice if you could just tell Excel every time there's a space, move the rest of the text to a new column? Or maybe you've got an email address of all of your customers and you want to group them by their company, but that information is stuck in the domain of the email address. Wouldn't it be nice if you could just split the cell anytime you saw an @ symbol? Or maybe you have a column with some text of like a code of some kind that's consistently formatted in a certain way, and you want to split that code up. And you wish that you could just draw a column divider between the second and third character of each cell. Well, good news, all of these actions are not only possible, they're simple with the Text to Columns tool in Excel. Now, if you've ever opened a CSV file in Excel, you've actually seen Text to Columns working. CSV stands for comma separated values. And that simple text file uses new lines for each row and commas in the place of column dividers to tell Excel when to split data into another column. That comma is what is known as a delimiter. And the Text to Columns tool allows you to treat any characters as a delimiter. There are common ones like tabs or commas, spaces or semicolons, but a delimiter can actually be any character like a dash or a slash or the @ symbol from an email address. So, in our sample file, you'll see we have 3 columns with 3 different types of data. We may want to separate a name, an email address, and a code with uniform formatting. We're going to split each of these individually using the Text to Columns tool, starting with name. As is always the case in Excel, the cardinal rule is select to effect. So first, we're going to select all the data that we want to break up, We can select the whole column and break it all up at once. Then, under the Data tab, or the Data menu, you can launch the Text to Columns tool. We see it here. The first question that you'll be asked is whether you want to split your data using a delimiter or a fixed width option. We'll talk about fixed width a little later, but delimited is by far the most common option that you're going to want to use. And it basically means that there is some kind of character that you want to turn into a column divider. Note that we won't just divide the data into two columns at the delimiter. It will literally remove the delimiting character from the text string and turn it into a column divider. On the next screen, you'll identify what that delimiter is. Note these common options, and in our case, it's a space. We'll check the space option, and note in the preview window what is happening to Doris J. Titterington. Every space turns into a column, which isn't ideal when your text isn't uniform, so you can see how Doris's last name is going to be in the wrong column, but we're just pretending to just need the first name, so this is still going to work for us. When you hit that next button, you'll have a few options for what you want to do with the separated data. Personally, I don't see much value in the pre-formatting of the data here, except this last choice of if you want to skip the import, which is sometimes useful. Like I could select these last two columns and skip those so they aren't imported. But I usually just keep it as general. And I do want to change my source location to keep the original data untouched. So I'm going to change that destination value to E2. If I left this alone, it would actually overwrite my original values and any columns to the right. So I'm going to choose E2, hit finish, and voila. Let's try this again for the email column. We'll select the data and launch the Text to Columns tool, again choosing the delimited. This time, we're going to use the other option of delimiter and put in the @ symbol. And you'll instantly see in that preview window how the second half of the email address splits out. I again want to change the destination field so I don't overwrite stuff in the next column, so I'll change the destination value to F2 and then hit finish. Note that you still have that email suffix, but if you wanted to get just the company name, you could strip out all of that .com or .net or .co.uk stuff by running the text to column tools again and using the period as delimiter, then skipping the import for those other columns like so. Note that I couldn't have done these two at the same time because both the period and the @ symbol are other options. Okay, let's quickly look at the fixed width options for when you have uniform data like our client ID column. The concept of this tool is super straightforward, though it's kind of tricky to execute. You are literally just drawing where you want the column divider to go by clicking on the ruler in the preview window. So with the data selected, we're going to choose fixed width, and you see that when I click, this divider appears. If you miss your mark, you can click and drag to move that divider around, or you can double click if you want to delete that divider. Once it's in the right place, which for us is between the second and third characters, you can hit next and see the same settings as before. I'll just choose a destination cell and hit enter directly, and ta-da, we've split our data at that point. That's Excel's awesome text to columns tool. Again, super useful for instances where you've got one column containing more than one piece of information and you need to break it apart. Definitely a tool worth knowing about that I find myself using pretty often. Give it a try yourself and we'll see you next time. You may think of Excel as simply a fancy calculator. But what makes it such an incredible tool is that rather than simply doing a calculation with a series of numbers, you can refer to the location of a number. So instead of just saying 4 plus 5 equals 9, you can say B2 plus C2 equals the total of whatever's in those cells. And as the cells change, so too does the answer. This ability to use cell references or the location of a cell by referring to its column letter and row number is at the heart of Excel's power. But you might not realize that there's actually two ways to refer to a cell, and that the one you're using actually doesn't refer to a specific location. It's what's called a relative reference. Let me show you what I mean.
Here we have an order for a bunch of different grocery products, each with a different unit cost and a different total units in columns B and C. And I want to calculate a couple of things about this order. We'll start with the total order cost. This is fairly straightforward. We'll write a simple formula where I multiply the unit costs in B5 times the total units in C5, and I get a formula B5 times C5. For my total with tax, I now want to take that total value and multiply it by my tax rate in F1. In this case, we'll say this cell equals the total order plus the total order times my tax rate in F1. So D5 plus D5 times F1. Seems like everything's working just fine, and of course we don't want to do this every time for every cell, so we'll select both of these cells, and using our autofill handle in the bottom right, a quick double click should copy those formulas down each column. But wait a minute, something went wrong.
Our totals column looks great, but our tax column is all messed up. What happened? Well, when you use a simple cell reference like we always do, usually just by clicking on the cell you want to refer to, you're actually using what's known as a relative reference, meaning relative to the cell you're calculating from. Think of it like giving directions. If I say you can get to my house by going 4 blocks south and 7 blocks east, where you start is going to affect where you finish.
Let's take a closer look at the formulas that we just created, and the total order column worked as we might expect. It didn't actually copy B5 times C5, it copied the relative references of 1 to the left times 2 to the left, or B6 times C6, B7 times C7, etc. Always the relative position based on where we start. However, that also occurred for the tax rate. We wanted the total order value to change. D5 should update to D6 and D7, etc., but the tax rate changed as well, from F1 to F2, F3, and in cell E8 we see this value error. That's because it turned to F4, which was this header word, and that threw everything off.
Instead, we want to always go to the same place regardless of where we start, like giving an exact address in directions, like go to my house at 123 Main Street, instead of the relative directions of 2 blocks up and 5 to the left. In Excel, the way we use an exact, or what's known as an absolute reference for a cell like F1, is to add dollar signs to the reference. Dollar signs lock the column and the row in place, so it will always refer to the same cell regardless of where you start from.
Let's try to fix our total with tax column. We're going to go back to this formula, and rather than referencing the relative position of F1 as 1 to the right and 4 up, we're going to add dollar signs, so make it $F, $1. Now I'm referring to the exact position of that tax rate. And when I select that cell and copy it down, we see the function update correctly. Let's try the same thing for our total with discount column. Here I want to take my total tax rate in cell E5, and I want to subtract E5 times our discount rate in F2, but I always want to refer to that discount rate. That needs to be an absolute reference. A keyboard shortcut to help here is the function 4 or F4 key on your keyboard. If you're on a Mac, you may have to hold down the FN button. That automatically adds dollar signs into whatever your cursor is in. So if I click in a different reference and hit the F4 key, you see it adds dollar signs here, and it actually toggles through all our different reference types, from relative to absolute, and then mixed references where just the row is locked, just the column is locked, or back to relative. Because we always want to refer to the discount rate in F2, we'll leave it as an absolute reference, and when I copy that function down, we see that we always get F2 as our discount rate. One more thing to keep in mind is that concept of a mixed reference. It's more rarely used, but occasionally I might want to have one formula that I copy both down and across, and in this rare instance, I might use a mixed reference. For example, here, I want to know how many boxes I need for boxes that can only take 5 units or 10 units for the different unit options. In this case, I want to make a formula that as I copy down always refers to the same number of boxes but different units, and as I copy across refers to different box types but the same unit. So in the first cell, G5, we'll write the formula equals C5 as a mixed reference where we only lock the column and a $sign C5 divided by the number of boxes in G3, but only where the row is locked, so G $sign 3. This one formula, as I copy both down and across, will always reference the right cells.
There you have it. Absolute versus relative references. This is a foundational principle in Excel that, if you aren't aware of, can bite you in the tuchus. Because it's going to seem fine in that first formula, but everything goes haywire when you copy it down to the other rows or columns. Remember, your absolute versus relative references will always help you save hours of heartache. See you next time. In the Master Rule of All Functions lecture, we introduced the concept of a universal syntax for functions, where every one of the 480 plus functions in Excel are written the same way, with the name of the function, then open and close parentheses, within which go the variables divided by commas. And it's these variables that make the function go. Every function has a unique ability, whether that is to sum a range, find unique values in a list, or maybe give different results if a value in a cell does or doesn't meet a logical condition. But to truly unlock the potential of Excel, it's not enough to just know how to use each of these functions individually. You need to learn how to combine functions together using a concept called nesting. This technique is incredibly powerful, as it lets you take advantage of the unique properties of different functions and compound them together to create custom calculations that meet your specific needs. The good news is, as long as you remember that universal syntax that we talked about, again, name of the function, open and close parentheses, within which go the variables divided by commas, nesting functions is relatively easy. That's because, like a series of Russian dolls, every variable inside of every function can, in essence, be another function. Let's see how this works with a few simple examples which will equip you to experiment with this concept in all sorts of new and complex ways. Let's start with a simple example in a random cell on a blank sheet. There's a function called the today function we saw in the dates lecture that gives you today's date as an always updating date. It has no variables, so the syntax is just the word today and open and close parentheses. Now, there are also some other great date functions, things like the year, month, day, or even weekday functions. Each of these only have one variable, a date. Although that weekday function, which returns a number corresponding to the day of the week, does have an optional return variable that changes the default of starting with Sunday as 1 to Monday as 1. Now, let's say that you wanted a cell that always showed the current month. A general rule of thumb when nesting cells is to think about the sequence you need Excel to follow, like what is the inside versus outside Russian doll? And start with the outside one and work your way in. So if we want the month to be the output, we'll start by writing the month formula with our universal syntax. Equals, then the word month, then the open parentheses. Now here's where nesting comes in. You can literally write the today function inside the month function. Just put today with those open and closed parentheses as if it were its own function. And then we got to remember to put that other closed parentheses at the end. Basically, instead of a value or a cell reference, we've used a function as the variable. Excel will always calculate these functions from the inside out, meaning first it's going to solve that today function, then put that result right into the month function, and then solve the month function. So voila, we have a single cell to house the month. I could do the same thing with any of those dates functions. We simply nest the today function inside of the date function, and you could get the current month like we have here, or we could do equals day and put the today function in there, and now we see the current day of the month. Let me demonstrate another usage with a slightly more complex function. Here I have an imaginary list of employee salaries, and I want to know how many of my employees make more than the average for all employees. There's a function called the COUNTIF function that has two variables in it, the range you want to count, and then a criteria that you might want to use to determine what to count. I want to count all the salaries that are higher than average of the rest of my salaries. So, because my output is a count, I start with the COUNTIF function. So equals, COUNTIF, and then we'll start with the open parens. Now the first variable that this function wants is the range to count. So I'll select all the salaries, and then a comma, and then the criteria, which is basically just a logic question. We'll use a logic symbol of greater than, which is above your period, and then, just like before, we're going to nest the average right into this function. So we'll write average, and then select the salary range, and put that in its own parentheses. Notice now how both functions are still following their universal syntax for their respective functions. Even notice how their respective parentheses get color-coded. We've simply nested one function as a variable in the count function. Now, conceptually, this would work, but one little quirk of some of the logic functions is when you are using logic statements instead of a static value, you actually have to do a little bit of a concatenate, something we covered in the concatenate lecture. So instead of just the greater than symbol and then the average function, we need to put the greater than symbol in quotes and then use the ampersand or and symbol to combine that with the average function. So we'll do that here now. And now, as long as I've got all those parentheses in place, hit enter and ta-da! We've combined the power of the average function with the power of the COUNTIF function to count the number of salaries higher than average. Keep practicing this nested function with the thousands of applications you'll suddenly see in your spreadsheets. A good sign that you could take advantage of this nesting concept is when you find yourself making a cell or even a whole column to hold one step of a multi-step calculation, where you later refer to the answer in that first cell as a variable in another function. Now, with nesting functions, you can save that effort, simplify your sheets, and do it all in one nesting function. Enjoy! Adding subtotals to a list can be done the hard way or the easy way. Guess which we're going to learn. First, let me clarify what I mean by a subtotal. Imagine you have a list of movies that came out in the last year, and each row has a movie name, maybe the genre, the date that it was released, the studio that made the movie, and the box office sales for that movie. A subtotal for this list of movies might be something like, what was the total box office sales for a given studio? Now, the hard way to do this would be to sort the list by studio so that all the movies for each studio are grouped together, then manually add a new row after each group, put a sum function for that studio, and repeat this process over and over manually each time the studio changes. Not only will that be a total pain, which could take you a bunch of time, but then if you ever wanted a grand total, a simple sum function of the total sales column wouldn't work because it would include all the subtotals that you just added. It would just make a total mess. So instead, what I'm going to do is show you a great tool in Excel that lets you add subtotals to any list automatically, and even gives you some super useful formatting tools that make that subtotaling a snap. So, here we have my imaginary list of movies. Now, before I show you the automatic subtotals tool, you do have to remember to sort your list by whatever field you're subtotaling. This groups all the items in that field together. So if I wanted to know the total box office sales for a given studio, first I'll sort by studio. Now, instead of manually adding a new row after each studio, let's go to the Data tab and click the Subtotals button. Quick point of order here, if this button happens to be grayed out, it's because either you didn't click in your list or your list is formatted as a table. Then this subtotal tool won't work. You could just convert your table back to a range and the subtotal button should light up. Okay, so I've clicked in my list, my button is on, so when I give that subtotal button a click, we see 3 main areas in the dialog box that appears, and then a couple of checkboxes at the bottom. Now, the first row is what you are subtotaling. In other words, what did you just sort by? The most common mistake when using this tool is to forget to change this first field to the column that's sorted, because what this tool is going to do is look down whatever column you choose here, and whenever the values change, it's going to add a subtotal row. And if you haven't sorted your list, that's going to be a mess because it's going to add a whole bunch of subtotal rows at random. So, for us, we're going to change that first drop down to Studio. The next drop down is what kind of total you want. For example, we just want to do a sum of box office sales, but you could do an average or a count or something like that, a max even. Finally, we're going to check in this list which column we want to sum. What are we adding a subtotal to? That's it. First, what you're subtotaling by, then how you're doing the calculation, then what are you calculating, in our case, box office sales. When you click enter, huzzah! The first thing you might notice is that Excel has automatically added these grouping lines along the left-hand edge. And note those numbers in the upper left corner of 1, 2, 3. The number 3 is just the fully expanded list. And if you click on the number 1, you get just the grand totals. But if you click on lucky number 2, you will see just the subtotals. And how cool is that? This is a great place, by the way, for a little bonus. You can't really copy these subtotals to another sheet because you'd copy all the hidden data as well. But if you select that list and use the keyboard shortcut of Alt semicolon, you'll actually select just the visible cells. And now when you copy, you're just going to copy those subtotals. Note that subtotal tool actually does add new rows to your list. It is modifying your original data set, and you can add a subtotal to more than one column, but you can't add different types of calculations to different columns that easily. You'd actually have to run this tool another time, which brings me to those checkboxes that we didn't talk about a moment ago. I'll launch this subtotals again while I'm clicked in the list, and note that remove all subtotals button in the bottom left. That would quickly get rid of them. But there's also this replace existing subtotal checkbox. This is checked by default because you usually just delete and then rewrite subtotals if you run it again. But if you wanted to do that challenge that I mentioned a minute ago of having different calculations for different columns in your subtotals, for example, if I wanted not just to have the sum, but also the count of movies by genre and the sum of box office earnings by studio, we can do that. Note that I did need to make sure that my list was also sorted so that it was grouped by studio, but also by genre within each studio. So now, when I do this new subtotal to say for a given genre, what's the count of movie, I'll uncheck the replace current subtotals box. And it will add more subtotals to give me the count of movies within each studio by genre. I love how fast this tool is to use, and have seen it be one of the biggest game changers for people who are managing lists and regularly calculating subtotals. The automatic subtotal could literally save you hours of work. And what are you going to do with all that newfound free time? Maybe tell all your colleagues how this subtotal lecture changed your life and how they should take it too. See you next time.